Hi, Holly. It's Professor Sebastian. I'm just going to give you a little bit of feedback here on your second exam in calculus and also talk to you a little bit about the final and how to get ready for that. So first, some nuts and bolts. When you submitted your exam and you sent me the work, you had a 33.05% on the exam. After my review, I was able to bring that up to 58.9%. So still not a great exam for you. I looked back at your first exam. I saw you had a 74 or 73-ish on that, and so your average on your two exams now is around a 66, and your overall average in the course right now is 66.34. So you're looking, you're sitting at the D plus range right now. So we really want to get you up there. Let's get you up into that C range. Okay, so let me get you some feedback here. Also, again, nuts and bolts. Before I get into the feedback on the exam, for the final exam, I just want you to understand how that's going to work. So it's the same number of questions, 30 questions, and it's 2.5 hours long instead of 2, just because it's more material. And why is it more material? So the first 50% of the exam comes directly off of exams 1 and 2. So so there's 30 questions, so 15 questions come directly off of exams 1 and 2. So make sure you understand exams 1 and 2 in that material. Review them well, make sure you know those questions, how to do them, and also review my feedback that I've sent you, and my video feedback I've sent you for both exams 1 and now exam 2. And then the second 50% of the course, so 25% of the exam will come from quiz 5. So that's another 7 or 8 questions on the final exam come off of quiz 5, which is what you have to get done here by the end of week 5. And then the other 25% come from the 2 homework assignments that are in the week 6. Now the final exam has to be taken on next Thursday or Friday. You do get a half hour longer, 2.5 hours, because of more material. But if you have any questions on that as you're studying, please reach out. Any questions at all? All right, let's talk about exam 2. So questions 1 and 2 you had right on your own. Question 3. We got to question 3. You had pretty much right. You had this one piece here on part B, with respect to x of u divided by v. So yes, you had the right quotient rule. Very good. You just put in the wrong number for v here. V was actually -3. So you read the table wrong. You read it, or you read these wrong. You took, what you took? You took v prime instead of v. V was -3. So you're off a little bit, but I increased that from 0.75 to 0.95. Question 4. I think when we go on to the next page, basically you were missing this last thing about the total distance. So the total distance, now they asked you the total distance from t equals 0 to t equals 2, but you had already figured out up above that the velocity is 0 at t equals 1 and 3. So at t equals 1, which is in the interval from 0 to 2, the particle stops. So when the particle stops, it could go in the other direction. So if you just do the time at the end minus the time at the beginning, you're going to maybe cut something off if it's going in the other direction. So you have to break it up at every time the particle stops. And you take the absolute value because distance is positive. We don't want a negative distance. I increased your score a little bit there, though, because you had some ideas on how to do that. Question 5. So right here, you just got this times wrong to reach its max height. So that's part D. So half of its max height is 125, not 250, right? It says how long it takes to reach half its max height. You got the correct max height, 500. Oh, wait a minute. That should be 250. I was looking at the wrong thing, I guess. No, that should be right, 250. Okay, so careful. This feedback is not quite right. I read, I don't know, I was trying to figure out what you did wrong there, so let's see. So you should have had 250 here. I guess it's just a matter of plugging into, yeah, probably it was just a matter of when you plugged it into the quadratic formula, you didn't have it right. That should still be 250. So be careful when you're looking at this. That should still be 250 like you have. So this number will be different, but it comes out to be that 7.32 and 42.68. Okay, so be careful. Those are not right according to this. So that should be 250 there. All right, and then the last part, part E, how long is the rock aloft? Well, you can just double this. It's 25 up, 25 down. Or you can look at when the position function is 0, because it's 0 at the very beginning when you're first throwing the rock up, and then it's 0 at the end when the rock hits the ground again. If you do that, that's an easy thing to solve for t. You get 0 or you get 50, so it's 50 because that's when it hits the ground again. Question 6. So you missed the third part of this question. So this would just be one appliance beyond 110 would be C of 111 minus C of 110, because C of 111 would be how many it makes to produce 111 appliances. Subtract off how much it costs to do the first 110 appliances, and you get 580. So it's C of 111 minus C of 110. That's what you want to do. Okay? All right. Number 7. So this derivative here, so it looked like you were trying to do the right thing here. You're trying to use the quotient rule. So dy dx, using this quotient rule, you had these kind of figured out right. It looks like you had, so if v is 1 minus sine x, v prime would just be minus cosine x, not a minus 1 times that. So it's not positive cosine x, it's negative cosine x. So when you have v, right, which is 1 minus sine x, that should be here, u prime minus sine x minus u, so minus 7 cosine x times v prime, which is minus cosine x. So simplifying this numerator gives you minus 7x plus 7 sine squared plus 7 cosine squared. This comes together, right? Factor out a 7, you get 7 times sine squared plus cosine squared. So this is just 7. So then you have minus 7x plus 7. You can factor out a 7. You get 7 times 1 minus sine x divided by 1 minus sine x squared. One of those factors of 1 minus sine x cancels, and you get 7 over 1 minus sine x. So you had the right idea. It looks like you took a little bit of a derivative wrong up here. I did increase your score. All right, so let's see, number 8. And number 8, you pretty much had it all right. You just forgot the minus sign right here. This minus sign should have been brought down as well. Minus, so it's minus everything. And then somehow the derivative here, 3 theta squared became 3 theta cubed. But you had squared to begin with. So anyways, you need the minus sign, and this should have been 3 theta squared. Otherwise, you did it right. So I increased your score good there. Let's see. Number 9, you had correct on your own. Number 10. So number 10 was really a simplification problem. I increased it up to 0.9. So with number 10, you did a great job taking the derivative. It's actually correct. Using the formulas, you got the correct derivative. The simplification is where you went wrong. And you forgot to bring this 2 times sine x 1 minus plus cosine x down. And then this simplifies in here. So this is not correct. I showed you how it simplifies in here. Okay, so this simplification, right? Just be careful, okay? Make sure you simplify correctly. 11. Okay, so 11, you had the first derivative correct. Okay, so that's correct. And then when you go to take the second derivative, you did the first part of the product rule, but you forgot the second half, right? So what you did here was you did the derivative of the first times the second, but you forgot the first times the derivative of the second. I mean, the derivative of the first times the second. So that's this guy, right? So you forgot the second half of the product rule, and then simplifying it would come out to this. So I increased that from 0 to 0.75. Number 12. All right, number 12, you missed these last few parts, and I've walked you through all these. So this is really, really kind of an important thing. Basically, it's taking care of all the derivative rules in one problem. So you need to understand these. If I want the derivative of f times g, that means I have to use the product rule, right? So the derivative of f times g is first times the derivative of the second plus the derivative of the first times the second. So basically, you had it right, except for this should have been a positive guy right here, positive 5, right? If you look at the table, g of, let's see, we have f prime, well, that's this team, right? So f prime, this was evaluated at x equals 3. So let's see, f of 3 is 4. So that's this 4. And then g prime of 3 is 5. So that should have been positive 5. So that's this first piece. And then f prime of 3 is 3 pi. And g of 3 is negative 1. So you get negative 3 pi. So you just had this positive 5 wrong, that's all. And then the rest of them, it looks like you didn't get to them, and you didn't, maybe, I don't know if you didn't understand them, if it was a time issue, because I did notice that, one of the things that happened to you is that you ran out of time, right? If we look down towards the bottom, you were not able to answer the last 6 questions, which that's disappointing. So we got to figure out how to get you through this a little quicker. Each question is worth about 3.3% of your grade. So when you miss 6 questions, you've missed almost 20% of your grade. And that's tough already. So by not answering those last 6, the highest score you can get is an 80. If you get everything perfect, then that's tough. We don't really want to do that to ourselves. So just try to figure out how we can go a little faster. So E, chain rule for F, another chain rule for G, another chain rule for H. So please just make sure you understand those. I won't necessarily walk you through them right now, but take a look at those. Make sure you understand what I'm writing, what the notation's saying, and what you do. So if you have any questions, you can reach out to me. This is an important problem to understand. All right. Where are we now? 13. So here's 13. You knew to use implicit differentiation. That's correct. And you wrote it out. And then you didn't answer it. And you didn't finish it. So let's see. When you take the derivative with respect to x of x cubed, you get 3x squared. That's correct. And the derivative sine of y. Now we want the derivative with respect to x. So y is some unknown function of x. So this is a chain rule. So it's cosine of y, right? Cosine of the outside, derivative of the outside, cosine of y, times the derivative of the inside. So times dy dx. You forgot that. And then when you do the derivative of x squared y to the fifth, you have a product rule. So the first one you have, if you take the derivative of the first times the second, you get 2x times y to the fifth. That's this term. But then when you take the first, x squared, times the derivative of the second, you need a chain rule for this. So 5 times y to the fourth, but then times dy dx. Then you just have an algebra equation to solve for dy dx. So put both terms with dy dx on the left side, any terms without dy dx on the right side, factor out the dy dx and divide by that. And you got the right answer here. So that's 13. 14. Similar type problem, you have to use implicit differentiation. So you got that right here. And then it was algebra to solve for dy dx. You just have to bring negative 6/7 x to the minus 1/7, divide by 6/7 y to the minus 1/7. So I showed you that, right? The 6/7 cancel. And then so we can get rid of these negative exponents, you flip these guys around. So it's now y to the 1/7 in numerator, x to the 1/7 in denominator. So now I can factor out x and y. I get minus y over x all to the 1/7. So then if I want the second derivative, I got to take the derivative of this, which I have to use a chain rule. So bring down the 1/7. So it's minus 1/7 y over x to the minus 6/7, right? 1/7 minus 1. So minus 6/7. And then times the derivative of the inside. So I have to use the quotient rule, low d high. So x dy dx minus high y d low, derivative of x is 1 over x squared. Then I have dy dx in my solution for the second derivative. So I have to take what dy dx was and plug it in. And then I just want to collect all the exponents and simplify as much as possible to get it down to this. Okay, so any questions on that, please don't hesitate. 15. So 15, you did almost exactly right. It's another implicit differentiation problem. So you did good all the way to here, and then all of a sudden your minus disappeared with the minus 15x squared. Other than that, you would have been exactly right. So the score increased from 0 to 0.95. All right, I'm going to run out of time because I can only do up to 15-minute video. So I'm going to stop this and start a second video for you.